So we attack some of the problems off of the Chapter 4 test, which was not one of our better tests, to be honest with you. Off of that test, we said that you want to make sure and know how to do problems like 1 through 19, 21 through 23. Said that the other day. And let's look at some problems I have picked out on those intervals. The first one that I picked out was number 2. Which says if f is 1 to 1, find an equation of its inverse. And the function is f of x is equal to 7x cubed minus 2. Now, so first things first, let's remember how to test to see if a function is 1 to 1. Do you remember the vertical line test tells us if we have a function? The horizontal line test tells us if we have a 1 to 1 function. Here we have an x cubed graph multiplied by 7, then moved down 2. So it looks something like this. It looks something like a snake, which does pass the horizontal line test because no horizontal line crosses more than once. So it is 1 to 1, and it does have an inverse. Now the big picture thing to remember about inverses is to find them, you switch the x and the y. So if we thought of f of x as y, then if we switch the x and the y, we'd have x equal to 7y cubed minus 2. And then we solve for y. So, to solve for y, we could add 2. So x plus 2 would equal 7y cubed. And divide by 7. So y cubed would equal x plus 2 over 7. So to solve for y, we'd cube root both sides. So we'd have the cube root of x plus 2 over 7 equal to y. And you know, if we wanted to be technical, we should probably rationalize a denominator, but I think I lived with it if you gave me this answer. Remember, if you want to refer to it as the inverse, you can call it f. I don't like that. What happened there? Let me erase that. F and the superscript 1, remember, means f inverse of x is equal to the cube root of x plus 2 all over 7. That's really what we were looking for on number 2 on the Chapter 4 test. Now, if you missed number 5, I'm going to be mad. It gives us 5 to the third equal to 125. We're supposed to write it as a logarithm. So the base is the subscript. So the little 5 goes down there. And a logarithm is always equal to an exponent. So the 3 goes over here. And that means the 125 has to go here. That would write the log of 125, base 5 is equal to 3. The problem following that is the same kind of problem, it just reverses it. Gives you the logarithm and asks you to write it with an exponent. Okay, number 8 is the next one I have circled here. write the expression as a sum, difference, or product of logarithms. Assume all variables represent positive real numbers. We have the log base A of, now some of you read this problem differently. What it really says is 8x to the 6th y. Some of you interpreted that as, in fact many of you did, as 8x times 6y. So some of you did the bottom problem. And if you did that, I didn't count it wrong. But many of you did not do the bottom problem correctly. Okay, let me show you why. Do you remember as we split these up, if I come from the numerator, I get a positive logarithm. But if I come from the denominator, I get a negative logarithm. Okay, so all of these factors over here are going to get a positive logarithm. Now, the problem is some of you saw 8x as one thing. Okay, but really 8x is two different factors. So, if I interpreted it this way, what we really should have had is log of 8 base A plus the log of x base A plus the log of 6 base A plus the log of y, bless you, base A. A lot of you left the 8 with the x and the 6 with the y, and I think I circled it, and I might even put split or something like that on it. So if you interpreted the problem in this fashion, then that's the answer that I was looking for. If you interpreted it in this fashion, at the top, then you'd split it into 3. You'd have the log of 8 base A plus the log of x to the 6th base A plus the log of y base A but then that 6 you can pull out in front of the logarithm. So if you interpret it that way, we're looking for the log of 8 base A plus 6 log of x base A plus log of y base A. Questions? Okay, then we move along. The next problem that I had picked out is number 10, which is the same kind of problem in the exact reverse. Here we have a difference of logs, log of 12 base 7 minus log of y base 7. And we're asked to write it as a single logarithm. So we're just reversing what we just did. But the same logic applies. If it comes from a positive logarithm, it's going to go in the numerator. If we have a negative logarithm, it's going to go in the denominator. So all we were looking for here is the log base 7. 12 is going to go numerator. Y is going to go denominator. Log base 7 of 12 over y. Okay. Next, we're going to tackle number 15. I need somebody in Anna to say something because it almost sounds like you guys are muted, even though I don't think you are, so I need to make sure that you're not. Okay. Awesome like a possum. Number 15 is an exponential equation. 4 to the x is equal to 21. And so to solve exponential equations, what we did was we took the log of both sides. Now you can either take the common log or you can take the natural log. Most of the time in class we use the natural log, but it's not wrong if you use common logs. So if we did that, we'd have the natural log of 4 to the x equal to the natural log of 21. The reason that we do that is now that it's a logarithm that allows me to move the exponent in front. So x times the natural log of 4 equals the natural log of 21. And to solve for x, then we can divide both sides by the natural log of 4. Gets those to cancel. The x is by itself. And according to my calculations, if you punch the natural log of 21 over the natural log of 4 in, by the way, when you do that, make sure you put parentheses around the 21. It's going to open parentheses for you. You got to make sure you close those before you hit divided by, and then it's going to do the same thing down here with the 4. Should turn out to be approximately 2.1962. I got a question for you. What if that problem would have had a 3 out here in front of the 4? How would that have changed how I worked the problem? You would. So that's the point I want to make. The first step is always to get the part with the exponent by itself first. So if you got something multiplied by it or something added to it, get rid of that first and then take the log of both sides. That's a common mistake that's made. Number 16 on that test, we can look at, had that kind of thing going on. The first thing you wanted to do was get the e to the 2x minus 2 by itself, so the first thing you needed to do was divide by 2. A lot of you tried to take the log right from the beginning here, and that's going to cause you trouble. So make sure you get the part with the exponent by itself first. Well, I want to look at numbers 17 and 18 because they caused a lot of havoc. Lots of havoc on 17 and 18. So let's try to get squared back around on those problems. 17 has a natural log of 3x minus 2 plus the natural log of x minus 2 equal to the natural log of 4. So we have a logarithmic equation, and we encouraged you on logarithmic equations to write each side as one logarithm first. So we need to rewrite the left side. Now, both of these, the 3x minus 2 and the x minus 2, they come from positive logarithms. So they're going to end up in the numerator. So I'm going to have the natural log of 3x minus 2 times x minus 2 equal to the natural log of 4. And then if you look back in your notes, the next part says either cancel logs or rewrite with an exponent. Well, here we can cancel logs because I've got a log on both sides. Again, the thinking is if a natural log equals a natural log, the only way those two natural logs are going to be equal is if the two things that you're taking the natural log of are equal. So we can cancel those. And our problem becomes 3x minus 2 times x minus 2 equals 4. We'll multiply all this out over here, so I have 3x squared minus 6x minus 2x plus 4 is equal to 4. And that's a quadratic equation. So we'll get a 0. Now these 4's are going to cancel. So I have 3x squared minus 8x is equal to 0. We can factor out an x, so x times 3x minus 8 is equal to 0, which gives me x equal to 0, or 3x minus 8 equal to 0. If you add 8 and divide by 3, you get x equal to 8/3. But on a logarithmic equation, we always have to check. Now, what are we checking? Well, if you remember, you cannot take the log of a 0 and you cannot take the log of a negative. So when we put these values back in, we shouldn't end up with the log of a negative or 0 anywhere. And notice if I put 0 in back up here, x minus 2, I'm going to get the log of negative 2, which I can't do. So 0 is not a solution. If you try 8/3 in, that's like 2 2/3. If you put that in here, 2 2/3 minus 2 is still positive, so that's okay. 3 times 2 2/3 is more than 6. Minus 2, that's going to be positive, that's okay. So the only solution to number 17 is 8/3. Don't forget that business where you got to check. A lot of students forget that. Okay, now how is that problem different from number 18, which has the log of the quantity x plus 10 minus the log of the quantity 4x minus 3 equal to 1. In the beginning, it's not different. It's logarithmic, so we want to write each side as one log, and right now I've got 2 logs over here on the left. So when I write it as 1, x plus 10 comes from a positive log, so it's going to go in the numerator. 4x minus 3 comes from a negative log, so it's going to go in the denominator. Okay, so we wrote each side as one log, at least the side that we could. Now, this time I cannot cancel logs because I don't have a log over here on the right side. So this is the one where we want to rewrite it. And it goes base to power is equal to this stuff. So class, here's my $10 question for you. What's the base on this problem? It's 10, because no base is written, it's a common log, it's 10. Good. So this 10 to that power of 1 has to equal this stuff. X plus 10 over 4x minus 3. Well, that's a rational equation. Let's clear out the denominator. So let's multiply by 4x minus 3 on both sides. So they'll cancel over here. So now what? 10 times 4x minus 3 would be 40x minus 30 equals x plus 10. That, at this point, is a linear equation. So let's put our x's on one side by subtracting x from both sides. And let's get them alone by adding 30 to both sides. So those cancel and those cancel. We have 39x equal to 40. So it looks like x is equal to 40 39ths. But we can't forget to check. Now 40 39ths is 1 and 1/39. That's just a little bit bigger than 1. Just a minute. So if I put 1 back into the original problem, or something a little bit bigger than 1, something a little bit bigger than 1 plus 10 is not 0 or negative. 4 times something a little bit bigger than 1 minus 3 is not 0 or negative. So we're going to be okay. So it looks like x is going to equal 40 39ths. So this is number 21 off of the chapter 4 and 3 test, which said to list all possible rational zeros. I have begun that process already. To do that, we take the factors of the constant, 52, over the factors of the leading coefficient, which is 1. The factors of 52 are plus or minus 1, plus or minus 2. What? 4 goes into 4 goes into 52. 5 doesn't, 6 doesn't, 7 doesn't, 8 doesn't, 9 doesn't, 10 doesn't, 11 doesn't, 12 doesn't, but 13 goes in 4 times. 26 goes in 2 times. And 52 goes in 1 time. So there are your factors of 52. Now, the factors of 1 are just plus or minus 1. So when I take the factors of 52 and put them over the factors of 1, all it does is generate the factors of 52, which would be this list here. Okay, so that's the first part of the problem. Find all the possible rational zeros. Now, the second part of the problem is we got to find which of those numbers works in the box. That can be a bit of a chore. Okay, but I'm going to cheat because I already know which one works in the box. -4 works in the box. So if you didn't know that, you just have to try some in until you got one that worked. This one should work. Let's see if I'm right. So now we're going to do synthetic division, so this gives us a chance to practice that as well. 1 and nothing is 1. -4 times 1 is -4. -2 and -4 is -6. -4 times -6 is 24. -11 and 24 is 13. -4 times 13 is -52. And there's the 0 that we need. So what we know right now is that -4 is a 0. We also know that x plus 4 is a factor. And remember what we're left with synthetic division. This is the remainder. This is the constant. -6x and 1x squared. So our other factors, if we have any other factors, are going to come out at x squared minus 6x plus 13. If I could, I would factor that. But there are not two factors of 13 that add up to -6. So what we had to do was use the quadratic formula. So here you go. Negative b would be -6, or 6, plus or minus the square root of. B squared is negative 6 squared, or 36. Minus 4 times A is 1, and C is 13. All over 2A, which is 2. Negative 4 times negative 1 is negative 4. Negative 4 times 13 is negative 52. So all this mess in here simplifies to what, negative 16? What are you guys going to do with the square root of a negative? Right, take an I out, so I have I times square root of 16. What's that? 4I. So really, we have 6 plus or minus 4I over 2. And I can't cancel any of that stuff right now because we have stuff that's being added. I can only cancel factors. So I can take a 2 out, leaving me 3 plus or minus 2I. And then the 2's will cancel. So my 3 zeros are 3 plus 2I, 3 minus 2I, and what, negative 4? Now I want to remind you of something that we talked about back when we were covering this stuff. Do you remember I said complex zeros, meaning ones that have i's, they come in conjugate pairs. So you know if you're given that 3 plus 2i is a 0, 3 minus 2i is also going to be a 0. That's always true. So keep that in mind. Now, I thought it would be good if we looked at number 23, but I don't like number 23. I think 23 is a little bit more involved than this type of problem that I'm going to give you on the test. So I'm going to make one up. So we'll call this pretend 23. How's that? And let's say we had f of x equal to x plus 2 over x minus 5, and we had the same set of directions. Sketch the graph, tell about intercepts, asymptotes, and test intervals. So did you guys get my email that I sent you with the formulas that I'm going to give you? Did you happen to look it over? Yeah. Okay. One of the things that's on that list is how to find both vertical and horizontal asymptotes. You want to look over that list because you want to know what's on it before the test, so that you recognize when you get a problem on the test, oh yeah, there's help for that on that list. So you want to know what's on that piece of paper. So you're going to want to take a look at it.
You want us to print it out, or are you going to print it out?
I'm going to print it out and put it on your test. That way I can guarantee that there's no little notes and stuff like that written on it. I know this is hard to believe, but some students cheat. Some students do. Actually, if you become a teacher, you just need to know this going in. There's two things students do as a general rule. Now, that doesn't mean all students do it, but students lie and students cheat. Okay? Commentary from you guys? Okay, well, anyway. What? Okay, so it said to say something about the intercepts. And it's always been true forever that if you want to find x-intercepts, you put 0 in for y. Which y is f of x here, right? So That means we'd have 0 equal to x plus 2 over x minus 5. To solve that, I would clear the x minus 5 by multiplying by it on both sides. It'd cancel over here, and over here I'd just get 0. So I'd have 0 equal to x plus 2. I don't know if you remember this or not, but I told you to find the x-intercepts, you could just put the 0 equal to the numerator, because that's what you're going to end up with anyway, which is what we did here. So it looks like we got an x-intercept at -2. I'm going to circle that because we're going to need it. Okay, for the y-intercept, we'll put 0 in for x. When we do that, if I put a 0 here and a 0 there, then I have 0 plus 2 over 0 minus 5, or -2/5. Okay, now we're supposed to tell about asymptotes, so we'll tell about vertical asymptotes and horizontal asymptotes. And here is what your notes say about that. For vertical asymptotes, it says factor first. Neither one of these will factor. Then cancel. Nothing here will cancel. Then take the denominator, set it equal to 0, and solve. So if x minus 5 is equal to 0, that means I'm going to have a vertical asymptote that is the line x equals 5. So I'm going to need those two things. You'll want to review the rules for horizontal asymptotes, but here's what they say. For the horizontal asymptotes, we looked at the degree of the numerator and the degree of the denominator. The degree of the numerator here is 1. The degree of the denominator is also 1, because that's what x is being raised to. If the degree of the numerator equals the degree of the denominator, then we have a horizontal asymptote made by the ratio of leading coefficients, which in this case are 1 and 1, and 1 over 1 is 1. So we have a horizontal asymptote at y equal to 1. If the degree of the numerator is less than the degree of the denominator, then y equals 0 is a horizontal asymptote. If the degree of the numerator is greater than the degree of the denominator, then we have no horizontal asymptote. All of that is on the formula sheet. Okay, and the last thing it says to do here is set up test intervals. Well, I hope that you remember to set those up. We use the x-intercepts, and we use the vertical asymptotes. So we're going to go -infinity to -2, -2 to 5, and 5 to infinity. We're going to take values off of each of those intervals. I choose -3. I already put 0 in, so I think here maybe I'll do 1 just to get another point. And from 5 to infinity, maybe I'll choose 6. So if I put the -3 in, I'll have -3 plus 2 over -3 minus 5. To be -1 over -8, or 1/8. Now we did a lot of that on our calculator using the table, so if you want to use the table, you can do that. So -3 in gives me an 1/8 out, and it tells me I'm always above the x-axis from negative infinity to negative 2. If I put the 1 in, I'll have 1 plus 2 over 1 minus 5, which is going to be 3 over negative 4, negative 3/4. So that means I'm always below the x-axis on the interval from negative 2 to 5. If I put the 6 in, I'll have 6 plus 2 over 6 minus 5, which is 8 over 1, or 8. Six in gives me 8 out and tells me I'm always above the x-axis on the interval from 5 to infinity. All right, let's take some of this information then and see if we can't do some damage on a graph. So hopefully you can see that on the paper because it's getting small on the screen. But I gotta have room to draw an XY plane, and that's why I'm scrunching it on in there. Scrunch it on in there. Yeah, I am. I'm scrunching it on in there. Okay, so I'm first going to put the intercepts on the graph. I had an x-intercept at negative 2, and I had another one at y-intercept at negative 2/5. Let's put our asymptotes on the graph. X equals 5. It's way out here. And y equals 1. Okay, then I can put some of these points down here that I figured out earlier. So let's put those on there. So negative 3 and positive 1/8. 1, 2, 3, and just an eighth up. Be like right in there. 1 and negative 3/4 be 1 right and 3/4 down. Be like right in there. 6 and 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8 will be way up here. Okay, so on this part of the graph down here, you can kind of tell what it's doing with the points that are there and the asymptotes the way they are. So the graph's going to have to do something like that. And here it's going to have to do something like that. And over here it's going to do some similar stuff. It'd be nice to have a few more points. So we could put like 7 in for x and 8 in for x and see what we get. Let's see, if I put 7 in for, see, is x plus 2 over x minus 5? So if I put 7 in, I have 7 plus 2 over 7 minus 5 would be 9/4. 9/2, thank you. So 7 9/2 would be a point. So 7 9/2 would be 4.5. 1, 2, 3, 4.5 right there. And if we put 8 in, 8 plus 2 over 8 minus 5 would be 10/3, which is 3 1/3. So 8 to the right, 1, 2, 3 1/3. So now you got a few more points and get an even better idea what the graph is going to do. Okie dokie, Smokey. Well, that means we have done selected problems off of all of our old tests except the last one. So why don't you kind of take a look at the last one. I'm going to pause here for a minute, so don't let me forget that we're paused. So this is number 8 off of the last test that we just took. Oops, that's not going to show up very good. It's kind of okay. We're supposed to expand x minus 2y to the 5th. And it says to either use the binomial theorem or Pascal's triangle. So let's say we used Pascal's triangle. So we got to go to the 5th row. Okay, well here's row 0. It's a 1. The first row is a 1 and a 1. The second row is a 1, a 2, and a 1. The third row is a 1, 3, 3, 1. The fourth row is a 1, 4, 6, 4, 1. And the fifth row, which I'm going to spread out here, is a 1. 1 and 4 is 5. 4 and 6 is 10. 6 and 4 is 10. 4 and 1 is 5, and then a 1. That didn't seem to be the problem. A lot of you came up with those. What we did seem to have a problem doing was fill in the x and the negative 2y appropriately. So let's see how we would do that. Remember, the x starts with the first coefficient, and it goes to whatever power is here, in this case 5. So 1x to the 5th, and then we're going to drop it by 1 as we move to the right. 5x to the 4th, 10x cubed, 10x squared, 5x, and then just a 1. Now, the next thing we need to look at is the negative 2y, and we do the same thing with it, except we go in reverse, right? So, back here, this 1 is getting a negative 2y to the 5th. Now I'm going to be all scrunched up like I always am. And then we're going to drop the power by 1 as we move to the left. So here we'll have negative 2y to the 4th, slip a plus in between those. Negative 2y cubed, slip a plus in between those. Negative 2y squared, put a plus in between those. Negative 2y to the 1st, put a plus in between those. And then x to the 5th isn't going to get a negative 2y. So that's how the problem is set up. Some of you did okay with that, some of you did not. Now, let's see how the problem finishes off. 1x to the 5th is just 1x to the 5th. So no big deal there. 5x to the 4th times negative 2y would be negative 10x to the 4th y. So no big deal there. So we got that one taken care of and that one taken care of. But look, here I have to square the negative 2y before I multiply it by 10x cubed. So I usually showed that as one step in class. Maybe I would have been better off putting in an extra step here. So I have 10x cubed, and if I square negative 2y times negative 2y is positive 4y squared. Plus, same thing here. I have to take 10x squared. I got to multiply that by whatever negative 2y to the third is. Now, negative to an odd power is going to give a negative, and 2y cubed is 8y cubed. So I've done both of those now. So back here I got 5x times, and here if I raise a negative to an even power, I'll get a positive, and 2 to the fourth power is 16 y to the fourth. Done with that one. And back here then, negative to the odd power, negative 2 to the fifth is going to give me a minus 32 y to the fifth. Okay, now we can finish this thing off. So I got x to the fifth, negative 10 x to the fourth y. That 10 times that 4 is going to give me positive 40 x cubed y squared. That 10 times that negative 8 is going to give me negative 80 x squared y cubed. Five x times 16y to the fourth is 80x y to the fourth minus 32y to the fifth. And that's the answer we were looking for on that problem. So you definitely want to be up to speed on a binomial expansion. All right, there is one other thing from Chapter 9 that's not on your test that I need to mention. Okay, that you could see on your final. So let's say I gave you a system of equations, and your system was x plus 2y is equal to 10, and 3x plus 6y is equal to, let's say, 20 here. Bless you. Okay, so Emily and Colin, do you guys want to use substitution or elimination here? I don't care.
Elimination.
All right. You going to eliminate x's or y's?
X.
So maybe multiply this by negative 3. Okay. If I do that, that'll give me negative 3x minus 6y equal to negative 30. If I do that, both of these cancel. I get 0 equal to negative 10. Now, we talked about this scenario in class. Do you remember what this scenario was?
It's not possible.
It's not possible, which means what? There's no solution. So that's one of the things that can happen. No solution. Now, let's change the problem just a hair. Let's make it x plus 2y is equal to 10. Let's make the next one 3x plus 6y is equal to 30. Now let's use elimination. Let's multiply by -3 again. So we have -3x minus 6y equal to -30. Yeah, everything cancels here, so we get 0 equal to 0. So this isn't the one that's no solution. This is an infinite number of solutions. And when you had this in your homework, there was a few problems that we did that said if you have a dependent system, which is what this is called when there's an infinite number of solutions, then sometimes it would say express x arbitrary. You remember that? So what did that mean to do? It meant we're going to write the solution as x and then whatever my y would look like. Now to figure out what your y would look like, take either one of these two equations, it doesn't matter which one, and solve it for y. I like the looks of the first one better. So if I do that, 2y is equal to -x plus 10. And divide by 2. So an acceptable solution, if they say to express x arbitrary, would be x comma -x plus 10 all over 2. That'd be what we're looking for. Now the other thing they could do is they could say express y arbitrary. So in that case, we'll have something for x and then y. And to tell what the x looks like, instead of solving the equation for y, we'd solve the equation for x. So if I took this equation up here and solved it for x, I'd have x equal to -2y plus 10. So to have y arbitrary, I could have -2y plus 10 comma y. So it just depends on which one they ask for arbitrarily.